In class, some people wanted to compare the relative orders of growth of the natural log function and the square root function. So let me now provide some intuitive words that will help you reason about these things, and we'll treat it more thoroughly later. So first, let's think about what does it mean to be a larger order of growth. So you know that like quadratic functions, for example, should be a larger order of growth than linear functions. And at least for this picture, larger order of growth seems to be the same as one function actually being larger than another. So here, for all of these positive x values, we've got, well, not quite all of them, but for the ones that we're seeing, we have that x squared is larger than x. Okay, well, what if we make our linear function steeper? So let's make it like 10,000x. So now it's so steep that it really seems as if the linear function is going to be larger than the quadratic. Of course, you know that eventually somewhere way up here, those graphs are going to cross. But certainly it doesn't look like they're going to cross from here. So one thing you could do is plug in some values. You could figure out what is an x value where the quadratic function is going to be larger than the linear function. I think it only takes a moment's thought. Oh, they're both f. I think it only takes a moment's thought to figure out that 10,001 is going to be that value. If I plug in 10,001 here, I've got 10,001 squared. If I plug in 10,001 here, I've got 10,000 times 10,001, which is a little bit smaller. So the point I'm trying to make here is what it means to be a larger order of growth is that that function is going to be larger eventually for large enough inputs. That's the concept. So if we're applying that concept, one thing you could do is let's look at our mystery functions, natural log x and square root x. So what I'm claiming is that if you go out far enough, eventually the function whose order of growth is larger should produce larger outputs. And certainly from this picture, it appears as if that is square root. But maybe you're still skeptical. Maybe you think like something weird is going to happen if you go out far enough. And if you actually try and work out values algebraically, it seems like a bit of a mess. So let's do another intuitive way to reason about this. I recommended in class that you think about inverses. So let's do a simple example with inverses. Here I've got x squared and x cubed. And again, intuitively, you know that cubic functions are a larger order of growth than square functions, quadratic functions. I'm going to restrict the domains here to just be positive because I think that's going to make a better picture. Okay, so now let's look at the inverses of these two, and we'll compare the order of growth of the inverses to the order of growth of the originals. So when I take inverses, graphically speaking, that's like reflecting them around the line y equals x. So if I had the inverse of x squared, that's going to be x to the 1/2. And the inverse of x cubed is cube root x, which is x to the 1/3, which again I'm going to restrict the domain of. Let me adjust the colors so that each function and its inverse are the same color. Alright, so now each function and its inverse are the same color. So you see here the cubic function in red, which has the largest order of growth. When you take its inverse, it's growing less quickly than the quadratic function inverse. So the idea is whatever function has the larger order of growth, when you take inverses, it's going to have the smaller order of growth when you take the inverse. And I think if you think for a moment about sort of intuitively what is growth about, it's like how far do you go up for every unit you go over. You can sort of think about why that should be the case, even just graphically when you do the reflection. All right, so let's apply that same reasoning now to the case of natural log and square root. So here, if I've got natural log x and square root x, we know that the inverses of those two are e to the x and x squared. So again, give me a second and I'll restrict the domains and I'll fix all the colors. All right, so here we are. Very clearly the function in blue, e to the x here, you know intuitively, is the larger order of growth compared to a quadratic. In fact, it's growing a heck of a lot faster than a quadratic is. And so, just like in the last example we saw, when we take the inverses of both, the faster growing function becomes the slower growing function when you take its inverse. So that's another kind of intuitive way that you can convince yourself about the relative order of growth of these things. All right, well, we're going to do this all in a more thorough, formal way later on, but I think that these natural ways of thinking about the question are going to be helpful in just your sort of daily work. So I hope this has helped. Good luck with the homework.